Ancient builders achieved stonework precision that our modern tools cannot match. The granite blocks at Puma Punku and the Great Pyramid fit together with microscopic accuracy, a feat that defies conventional history. By the end of this, you will understand the hidden techniques and lost knowledge that made such engineering possible. How did they cut stone without leaving a single tool mark? What forgotten methods allowed them to move 100-ton blocks? What do you believe is our greatest unanswered question about the past? Stand before the colossal walls of Sacsayhuamán in Peru, and you are faced with a paradox of the past. Massive stones, some weighing over 100 tons, are stacked high, their edges a complex tapestry of zigzags and angles. The most astonishing detail is not their size, but the space between them, or rather, the lack of it. Not even the thinnest razor blade can be inserted into the joints. These are not simple blocks laid one on top of another. They are irregular polygons, each one uniquely carved to fit its neighbors with microscopic precision. This is not mere masonry. It is a three-dimensional stone puzzle of incredible complexity, built without a single drop of mortar. And for centuries, these very walls have withstood powerful earthquakes that have leveled modern cities, proving their builders understood something profound about stability that we are only now beginning to grasp. How do you create such a perfect, interlocking fit without lasers, without computer modeling, without even a standard unit of measurement? The answer lies in a lost method of working with stone that goes far beyond chisels and brute force. The surfaces of these stones are not flat, they are subtly convex. When you look closely, you see that each face is slightly rounded, creating a complex interface that locks the entire wall together under its own immense weight. This means the builders weren't just cutting straight lines, they were carving intricate, compound curves across multiple planes for every single block. The level of geometric foresight required is staggering, suggesting a knowledge of seismic dynamics and structural engineering that textbooks tell us did not exist. This was not a trial and error process, it was a precise and repeatable technique, a secret method that turned ordinary rock into an indestructible, self-locking system. What kind of knowledge creates such perfection, and why did it vanish from history? This same mystery of impossibly smooth surfaces is carved into the very heart of ancient Egypt. Examine the granite sarcophagi found deep within the Great Pyramid, and you will find something astonishing, or rather, the complete absence of something. These massive stone coffins, hewn from incredibly hard materials like rose granite, show no visible tool marks. Their surfaces are flawlessly smooth, with a polish so perfect it feels like glass. Modern engineers are baffled. To carve granite today, we use diamond-tipped saws and routers, tools that inevitably leave behind microscopic scratches and telltale grooves. Yet these ancient artifacts are pristine, as if the stone was shaped not by physical force, but by some other, far more gentle process. How do you achieve such a finish without any grinding or filing? The absence of evidence here becomes a form of evidence itself, pointing toward a technology that has completely vanished from our historical records. Some researchers propose these builders used sonic vibration, a method where specific sound frequencies could make the granite temporarily malleable, allowing it to be worked like soft clay. Others suggest a chemical process, perhaps a plant-based solvent that could weaken the molecular bonds of the quartz in the granite, letting artisans scoop the stone away before it rehardened. There is even speculation about lost abrasives, substances far more effective than the sand or corundum we know were used in other contexts. Imagine a paste or slurry so potent it could polish granite to a mirror finish without leaving a single scratch. These are not wild fantasies, but serious hypotheses born from confronting an object that should not exist according to our understanding of the past. The sarcophagus stands as a silent, immaculate witness to a method we have yet to rediscover, a technique that rendered one of the hardest stones on Earth as pliable as butter. What does it say about our history when the physical evidence so clearly defies our accepted narrative of technological progress? This geometric genius extends far beyond walls and tombs, appearing in the most unexpected places. Scattered deep within the jungles of Costa Rica lie hundreds of perfectly round stone spheres, some as large as small cars. They are so impeccably spherical that modern measuring tools can find almost no deviation from a perfect ball. How could a culture, presumably using only stone tools, achieve such a flawless three-dimensional form? The answer remains elusive, pointing toward a sophisticated, shared geometric knowledge that spanned the globe. This precision reaches its absolute peak with the Great Pyramid of Giza. Its base forms a near-perfect square, level to within less than 1 inch across its entire 13-acre foundation. To put that in perspective, that is like perfectly leveling a surface the size of several dozen football fields using only ancient tools, a feat that would challenge our best modern engineers with their laser levels and GPS. Even more astounding is its alignment to the Earth itself. The 4 sides of the pyramid are oriented almost perfectly to the 4 cardinal directions, north, south, east, and west, with an error margin so tiny it is almost negligible. This is not a coincidence. This kind of accuracy reveals a profound understanding of astronomy and geodesy, the science of measuring the Earth. The builders were not just stacking stones, they were aligning their creation with the fundamental axes of the planet and the cosmos. They worked with a consciousness of celestial patterns that modern science is only beginning to fully appreciate. This was architecture as a conversation with the universe, a permanent monument built by people who saw their world not as a flat plane, but as a spinning sphere in a vast, ordered system. What does it mean when the most enduring structures from our ancient past demonstrate a knowledge we thought was born in our modern era? Could a simple plant have held the secret to carving solid granite? Across the Andes, oral histories passed down for generations tell of a powerful liquid, a juice extracted from specific local plants that could soften stone. When Spanish chroniclers first arrived, they recorded Incan stories describing how their ancestors would apply this mysterious substance to rock, making it pliable, almost like clay. This was not magic, it was applied science. The stones could then be shaped, molded, and fitted together before the material re-hardened to its original, indestructible strength. This single technique could unravel the mystery of the seamless joints at Sacsayhuamán and the flawless surfaces of the Egyptian sarcophagi. It would explain how builders carved intricate designs and perfect curves into some of the hardest stones on Earth without leaving a single tool mark. Modern laboratory experiments lend surprising credibility to these ancient accounts. Researchers have found that certain organic compounds, particularly those from plants high in acidic saps or specific enzymes, can actually weaken the molecular bonds in silicate-based stones like granite. The chemical does not melt the rock, but it temporarily disrupts the crystalline structure, making the surface soft and workable. Imagine being able to press your thumb into granite as if it were potter's clay, smoothing it to a perfect finish before it solidifies again. This would represent a profound botanical and chemical knowledge, a deep understanding of the natural world that allowed these builders to manipulate their very environment. The knowledge was not lost because it was ineffective, but perhaps because it was so specialized, so guarded, that it vanished when the cultures that nurtured it fell. What other natural secrets, once common knowledge, are we still struggling to relearn today? But sound as a tool for shaping stone might seem like a myth, yet modern science is beginning to catch up with these ancient whispers. We can now observe that specific, carefully controlled sound frequencies have a profound physical effect on matter. In laboratories, researchers use sonic levitation to make small objects, from water droplets to tiny pieces of wood, float in mid-air. The principle relies on standing waves of sound, which create points of high and low pressure that can counteract gravity. While we are not levitating pyramids, these experiments prove that vibration is a tangible, physical force capable of manipulating solid materials. If a specific resonant frequency could be found for a particular type of stone, it might temporarily change its state, making it less rigid, less brittle. The immense block could become temporarily pliable, allowing it to be molded and shaped with minimal physical effort. This would not be magic, but a highly advanced application of acoustic physics. The stone would not be cut but persuaded. It would be sung into its perfect, seamless form, leaving behind no tool marks because no physical tool ever touched its surface. This single concept could explain the impossible smoothness of the granite sarcophagi and the interlocking curves of Andean walls. The builders were not just masons, they were masters of vibration, conducting the very substance of the earth with precise harmonic command. What if the most enduring monuments of our past are not just piles of rock, but frozen songs, their builders' knowledge encoded not in writing, but in form and frequency? The idea of cutting stone with water sounds like a modern invention, yet evidence carved into ancient quarries suggests otherwise. At sites like Ollantaytambo in Peru, you can find massive granite blocks displaying long, perfectly straight grooves. These are not the rough, chipped marks left by pounding stone. They look instead like the clean, precise cuts of a modern industrial saw. So how could water achieve such a feat? The principle is simple physics. When water is forced through a narrow opening at high pressure and mixed with an abrasive like sand or crushed quartz, it transforms into a relentless cutting stream. This high-velocity slurry acts like a liquid blade, capable of slicing through granite with astonishing efficiency, and it leaves behind those distinctive, parallel marks we see today. The technology needed to harness this power could have been remarkably elegant, relying on the natural landscape itself. A water source from a high mountain stream, channeled through a leather hose or a hollowed-out log, would build immense pressure simply through gravity. By focusing that jet through a hard, precision-shaped nozzle, perhaps made of stone or durable metal, the builders could direct a cutting force more than capable of shearing through multi-ton stone blocks. This method explains not only the straight cuts, but also the ability to create complex shapes and deep, narrow channels that would be nearly impossible with primitive chisels. The very environment provided the power, and their ingenuity provided the control. It reveals a profound understanding of hydraulics and material science, turning a simple river into the most precise stone-cutting tool imaginable. What other natural forces readily available all around them did these ancient engineers learn to command with such effortless mastery? Fire offers a powerful but gentle key to unlocking stone. While we see heat as a destructive force, ancient builders may have understood it as a sculptor's tool. The technique is known as thermal shocking, a process of using extreme temperature change to precisely fracture rock. Imagine a massive granite block embedded in a quarry. To free it, builders could have built small, controlled fires along the line where they wanted the stone to split. As the rock heated, it would expand. Then, by suddenly dousing the hot surface with water, the outer layer would contract violently from the rapid cooling. This creates immense internal stress, a battle between the expanding core and the shrinking shell, and the stone has no choice but to crack, perfectly following the heated line. This is not a chaotic explosion, but a controlled, predictable fracture. It would require a deep, intuitive knowledge of the stone's properties, understanding how different types of rock react to heat and cold. Evidence for this is not just theoretical. At ancient quarry sites around the world, archaeologists have found layers of charcoal and soot concentrated in straight lines and geometric patterns, patterns that do not look like the remains of random campfires. The very stone in these places sometimes bears the telltale signs of thermal stress, with discoloration and microfractures that speak of targeted application. This method transforms an impossible task into a manageable one. Instead of weeks of brutal labor with stone hammers, a small team could quarry a multi-ton block in a single day using little more than firewood and water. It is a brilliant, almost elegant solution, turning the fundamental physics of the material against itself. How many other ancient secrets are hidden in plain sight, disguised as simple elements like fire and water? The mastery of these builders was not in overcoming nature, but in persuading it to do the work for them. The challenge of carving these stones pales before the question of how they were moved. Across continents and cultures, from the plains of Lebanon to the remote shores of Easter Island, our ancestors transported stones of unimaginable weight. At Baalbek, a single monolith known as the Stone of the Pregnant Woman weighs an estimated 1,200 tons. That is heavier than a fully loaded jumbo jet. How do you move a small mountain without wheels, without steel cables, without diesel engines? The answer lies not in a single secret, but in a sophisticated combination of simple physics and brilliant logistics. Imagine a massive stone block resting on a wooden sledge. Now, imagine workers pouring water onto the path ahead, turning the earth into a slick, muddy slide. This simple act of lubrication drastically reduces friction, turning an impossible drag into a manageable pull. Experiments have shown that on a slick, clay-based path, a team of just a few dozen people could move a stone weighing many tons. But for the truly colossal blocks, something more was needed. This is where the principle of the roller system comes into play. Placing a series of logs underneath the sledge creates a continuous, moving roadway. As the sledge is pulled forward, workers behind it would pick up the logs that had just passed underneath and rush them to the front, creating an endless loop of motion. It is a slow, methodical process, but an incredibly effective one. It transforms a grinding, static pull into a dynamic, rolling advance. The builders understood that the real challenge was not pure strength, but overcoming inertia and friction. They may have even used counterweight systems, similar to a giant seesaw, to help lift and maneuver stones up inclines or over obstacles. This was not brute force, it was applied physics on a monumental scale. The transportation of a single block was a carefully choreographed performance, a testament to planning, coordination, and an intimate understanding of the fundamental laws of the physical world. The stones did not just move, they were persuaded to travel, guided by minds that saw solutions where we might only see obstacles. What does this tell us about a society that could organize such a feat, marshalling labor and ingenuity to make the impossible seem almost effortless? The stones themselves were only part of a much grander design. Across the globe, ancient builders embedded a profound celestial knowledge directly into their architecture, aligning massive structures with the sun, moon, and stars. At Stonehenge, the great heel stone frames the rising sun on the summer solstice with breathtaking precision, a solar event marked for millennia. In Egypt, the great temple of Karnak was oriented so that on the winter solstice, the setting sun would shine directly down its main axis, illuminating the inner sanctuary with a beam of light. This was not guesswork. This required generations of meticulous observation, a deep understanding of the Earth's slow wobble on its axis, and the ability to translate that cosmic data into physical stone on a colossal scale. These were not just buildings, they were permanent calendars and observatories, their alignment so accurate they still function today. The precision of their stonework was not an end in itself, but the necessary foundation for this higher purpose. A wall that is even a single degree out of alignment would fail to capture that perfect solstice sunrise. A doorway that is not perfectly plumb would not frame the rising of a specific star. The microscopic joints and flawless surfaces were the prerequisites for a technology of cosmic connection. The builders were not merely constructing shelters, they were weaving the rhythms of the heavens into the fabric of the earth, creating a sacred dialogue between the human world and the universe. What does it mean that the most precise stonework in human history was created not for palaces or fortifications, but for tracking the silent, majestic dance of the cosmos? Even the smallest details carved into the hardest stones tell a story of impossible technology. Deep within Egyptian artifacts, particularly in sarcophagi and temple blocks made of granite, diorite, and basalt, you can find the unmistakable evidence of advanced drilling. These are not rough, hand-powered borings. They are clean, circular holes that plunge inches deep into some of the most durable materials on Earth. Inside these holes, a silent witness remains, a series of perfectly uniform spiral grooves running along the inner wall. These grooves are the fossilized record of the drill bit's path, and they reveal something extraordinary. The spacing between each groove is incredibly consistent, indicating the drill penetrated the stone at a steady, unvarying rate. This kind of precision implies a machine that could maintain a constant pressure and a constant rotational speed, something we would normally associate with a modern, powered drill press. To achieve this by hand with a bow-driven tool is almost unthinkable. The human arm tire's pressure fluctuates, and the drill bit would inevitably slow and speed up, creating uneven, ragged grooves. The ancient grooves tell a different story, one of relentless, machine-like consistency. So what kind of tool could possibly have done this? The most straightforward theory suggests the use of tubular drills. Imagine a hollow copper tube, its cutting edge charged with a powerful abrasive paste, perhaps made from crushed corundum or even diamond dust. As the tube was rotated, this abrasive slurry would do the actual cutting, grinding away a circular channel in the stone. This could explain the hollow core that is often left behind, a solid cylinder of rock that could be snapped free from the center. Yet, even this sophisticated method has its problems. To achieve the feed rate seen in these holes, the drill would have needed to sink into the granite at a pace that would astonish modern machinists. Some calculations suggest the drill was sinking into this immensely hard stone with a pressure that would be difficult to achieve even with today's equipment. This has led to more radical proposals. Could the builders have harnessed ultrasonic vibration? This technology, which we use today for precision cutting, involves vibrating a tool at incredibly high frequencies, thousands of times per second. Applied to a drill bit, this vibration would make the abrasive slurry far more effective, allowing the tool to glide through the granite as if it were soft wood. The evidence on the ground, or rather, in the stone, forces us to confront a reality where our timeline of invention is fundamentally flawed. The spiral grooves are not just markings, they are a precise data log of a lost industrial process, a technology that clearly existed but whose name and mechanism have been completely erased from our collective memory. The spiral grooves in ancient granite are a testament to a cutting force far beyond simple copper tools. To carve such hard stone, the builders needed something even harder, and they found it in the very earth beneath their feet. This leads us to a fifth crucial technique, the use of crystal-enhanced abrasives. Imagine a paste not of simple sand but of finely crushed diamonds. Diamond is the hardest natural substance known to man, and when ground into a fine powder and mixed with a liquid or oil to form a slurry, it becomes an incredibly potent cutting agent. A copper saw by itself is too soft to scratch granite, but that same saw, dragged back and forth while charged with a diamond dust paste, would transform into an effective cutting tool. The microscopic diamond particles, each one a tiny, indestructible blade, would do the real work, grinding away the stone particle by particle. This method elegantly explains the impossible precision we see. It accounts for the flawless, polished surfaces without any tool marks because the stone wasn't chiseled. It was gradually, meticulously abraded to a perfect finish. The evidence for this is not just in the finished product, but in the historical record. We know that ancient cultures across the world had access to these ultra-hard minerals through vast and sophisticated trade networks. Corundum, the mineral that gives us rubies and sapphires, is harder than quartz, the primary component of granite. Crushed quartz itself could have been used on softer stones. The real secret, however, may have been in the preparation. This was not a matter of simply crushing rocks with a hammer. To achieve an effective and fast-cutting abrasive, the crystals needed to be ground to a specific, uniform size and then mixed with a binding agent, perhaps a plant oil or tree sap, to create a consistent paste that would stick to the tools. This represents a form of ancient materials science, a chemical and mechanical knowledge that has been largely overlooked. It turns the narrative of primitive stone working on its head. The builders were not struggling with inadequate tools. They were masters of pyrotechnology and mineralogy, creating industrial compounds that allowed them to work stone with a control we would struggle to replicate without modern machinery. The true innovation was not the copper tool in their hand, but the intelligent, formulated paste that gave it power. Moving a stone is one thing, but placing it with perfect precision is an entirely different challenge. For the final, delicate act of setting a 100-ton block into a seam no wider than a hair, ancient engineers turned to the silent power of leverage. They understood that a small force applied intelligently could move a great weight. This was not about pulling harder, but about pulling smarter. Imagine a massive obelisk lying on the ground, needing to be raised upright. A simple lever alone would be useless against such immense weight, but a compound system using a series of levers and counterweights changes everything. Builders could have first stacked stone or sand counterweights on one end of a giant, pivoting timber frame. As they carefully removed material from the counterweight side, the obelisk would begin to pivot upward, controlled inch by inch. This method transforms an impossible lift into a series of manageable, tiny adjustments. The same principle applies to sliding a block into its final, perfect position. By using multiple levers inserted at strategic fulcrum points, a small team could nudge a colossal stone forward, backward, or sideways with almost surgical control. Each lever multiplies their strength, turning the push of a few individuals into a force capable of maneuvering a mountain. This is the essence of mechanical advantage, a concept we formally attribute to the ancient Greeks, yet the physical evidence suggests it was mastered and applied on a monumental scale thousands of years earlier. Their leverage systems were the hydraulic cranes of their era, a sophisticated technology of timber and stone that allowed them to defy gravity itself, placing each block with a quiet, deliberate accuracy that still defies belief. How many other fundamental laws of physics did they discover and apply, leaving behind no written formulas, only the immovable proof of their work? The very substance of the stones themselves may be the ultimate secret. What if the most intricate blocks were not quarried at all, but were instead mixed and poured like modern concrete? This is the radical proposal of the geopolymer theory, a hypothesis that suggests ancient builders had mastered the art of creating artificial stone. Imagine a craftsman not with a chisel but with a bucket mixing a slurry of locally available limestone, water, and a secret reactive agent, perhaps a specific plant ash or mineral compound. This geopolymer paste could then be poured into pre-formed wooden molds, creating any shape imaginable, from the perfect spheres of Costa Rica to the jigsaw puzzle polygons of Sacsayhuamán. Once hardened, this man-made stone would be chemically identical to natural rock, yet it would bear none of the telltale scars of physical carving. This single idea would unravel the greatest mysteries all at once. The flawless, seamless joints exist because the stones were cast to fit each other perfectly. The absence of tool marks is explained because no tools were used for shaping. The impossibly smooth surfaces of the granite sarcophagi become the natural result of a polished mold. The evidence is not just in the shapes, but in the chemistry. Laboratory analysis of stones from the Great Pyramid and other ancient sites has sometimes revealed the presence of synthetic minerals and air bubbles, anomalies that are difficult to explain if the blocks were simply cut from a quarry. If this theory is correct, then the builders were not master stone cutters, but the world's first materials scientists. Their genius was not in moving mountains, but in knowing how to grow them, creating perfect building blocks on demand from the very earth beneath their feet. This technology would represent a lost branch of chemistry, an applied knowledge so advanced it allowed them to bypass the most difficult physical challenges of construction entirely. What we have been admiring for centuries as the peak of stone carving might not be carved work at all, but the world's most durable and sophisticated pottery. How does our understanding of the past shift when the stones themselves begin to speak, telling a story not of brute force but of alchemical genius? That mirror-like finish on ancient granite is more than just a surface detail. It is a technological signature. Walk through the halls of the Cairo Museum, and you will see Egyptian statues carved from diorite and granite that catch the light with the perfect, unwavering gleam of a modern glass mirror. This is not a simple sheen from hand rubbing. It is a flawless, optical-grade polish achieved on one of the hardest stones on Earth. To understand the achievement, consider how a modern lapidary creates such a finish. It is a multi-stage process, beginning with a coarse abrasive to remove the bulk of the material, then moving to progressively finer and finer grits, each one erasing the microscopic scratches left by the previous stage. The final polish might use a paste of diamond dust or cerium oxide on a soft, spinning felt or leather wheel. The ancient builders seem to have followed an almost identical protocol. The sheer consistency of this polish, from the colossal Olmec heads in Mexico to the granite sarcophagi in Egypt, tells us this was not a rare, lucky result. It was a repeatable, industrial-grade finishing technique. How could they have managed it without high-speed rotary tools? One compelling theory points to leather polishing wheels. Imagine a wheel crafted from tough, flexible animal hide, perhaps turned by a simple bow drill mechanism or even by hand. This wheel would be charged with an abrasive slurry of the finest possible diamond or corundum dust. The leather, being slightly soft, would conform to the curves of the statue, applying the abrasive evenly across complex contours to create that uniform, reflective surface. Yet another possibility moves beyond mechanics entirely into the realm of chemistry. certain acidic compounds derived from plants can create a chemical reaction on the surface of silicate stones. Instead of grinding the surface smooth, this reaction might selectively dissolve the microscopic high points, effectively fusing the surface into a smooth, glassy layer. This would explain the complete absence of any directional scratch patterns, as the finish was achieved not by abrasion, but by a molecular-level transformation. The true secret may have been a combination of both, a final chemical treatment applied after the finest mechanical polishing to achieve that ultimate liquid shine. This mastery of surface science implies a global community of builders, or at least a shared corpus of knowledge that understood materials on a level we are still striving to comprehend. Their legacy is not just in the stones they left behind, but in the perfect, silent reflection staring back at us, a challenge etched in light and stone. These flawless stone surfaces and celestial alignments hint at a deeper layer of knowledge, one where architecture became a language for mathematics itself. The Great Pyramid of Giza is perhaps the ultimate example, a structure that functions as a massive, silent mathematical textbook. Its base perimeter, when divided by its height, gives a value remarkably close to 2 times pi. This is not a random number, it is the fundamental constant that defines the relationship between a circle's circumference and its diameter, a relationship European mathematicians would not formally define for thousands of years. Even more profound is the appearance of the golden ratio, a special number approximately equal to 1.618, found repeatedly in the pyramid's proportions. This ratio, often called phi, appears throughout nature in the spiral of a nautilus shell and the arrangement of sunflower seeds, representing a universal standard of beauty and efficiency. The builders did not just know these numbers, they encoded them into the very fabric of their most sacred monument. This was not merely advanced engineering, it was a philosophical statement. The stones were cut with such precision because they were meant to be more than building blocks. They were the physical embodiment of perfect mathematical ideals. By creating a structure that harmonized these cosmic constants, the pyramid became a bridge between the tangible world and the abstract realm of numbers. The builders saw no separation between the geometric perfection of their blueprints and the spiritual significance of their work. Their goal was to create a resonance, a harmony between the human-made world and the mathematical order they observed governing the universe. This represents a holistic vision of knowledge that our modern, specialized world has almost entirely lost. We have mathematicians who work with abstract formulas, and we have engineers who build with physical materials, but these ancient masters were both simultaneously. For them, a perfectly joined stone was not just a technical achievement, it was a verse in a poem written in geometry, a permanent expression of a universe built on numbers. What does it mean that the most enduring structures from our past are not just piles of rock, but 3-dimensional equations, waiting centuries for us to learn how to read them? The true secret behind these perfect joints and celestial alignments lies in the invisible lines the builders followed. How do you ensure that 2 stones carved miles apart will fit together without a millimeter of error, or that a wall stretching for hundreds of feet remains perfectly straight? The answer is a measurement system of incredible sophistication. These engineers did not work with rough approximations. They used standardized units, likely derived from the natural world, perhaps a specific fraction of the Earth's circumference or a fundamental proportion of the human body, like the cubit. This was not a simple stick for measuring, it was a reproducible constant, a universal key that allowed teams across vast distances to work in perfect harmony. Without such a standard, the Great Pyramid could never have achieved its near-perfect square base, or its sides so precisely aligned to the cardinal directions. Different crews working on different faces would have introduced tiny errors that would have compounded into visible misalignments, yet the structure is a testament to unified execution. This implies the existence of a central bureau of standards, a place where the master measurement rods were kept and from which calibrated copies were distributed to every foreman on the project. Their ability to maintain this calibration over decades of construction is a logistical marvel in itself, but their tools went beyond simple rods. They almost certainly employed advanced optical devices. Imagine a long, water-filled trench acting as a perfectly level reference line, its still surface providing a true horizontal plane across any distance. For vertical alignment, a simple plumb bob, a weight on a string, uses gravity to establish a flawless vertical line. For long-distance straightness, they may have used sighting tubes, primitive theodolites that allowed them to peer along a line and ensure that every stone was placed on the correct trajectory. These are not complex machines, but their application with unwavering discipline produced results that can still baffle us today. The stonework is merely the physical manifestation of this deeper, more abstract genius, the final expression of a culture that had mastered the art of measuring their world with an accuracy we would struggle to achieve without digital aids. Their greatest invention was not the lever or the drill, but the standard itself, the invisible rule that made every impossible cut and every perfect alignment not just possible but repeatable. Behind every perfect stone was a perfectly organized team of builders. The microscopic joints and celestial alignments we marvel at today could only have been achieved through a social technology as advanced as their physical tools. This was not a chaotic mob of laborers, but a structured, hierarchical society of specialists. Imagine the construction site for a project like the Great Pyramid. There would not have been one single workforce, but many distinct guilds. One team of master surveyors would have been responsible for the initial layout and astronomical orientation. Another team of expert quarrymen would have known exactly how to fracture and extract blocks with thermal shocking. A separate group of transport specialists would have managed the rollers and lubrication for moving the stones, while the final, most skilled group of finishers and setters would have handled the delicate work of placing each block into its perfect interlocking position. Each team operated with its own set of secrets, its own master craftsmen, and its own apprentices. This division of labor was the engine of their precision. A quarryman did not need to understand the finer points of celestial alignment, and a transport expert did not need to know the chemical formula for the polishing slurry. Each person was a master of their specific domain, and this deep specialization is what allowed for such incredible efficiency and accuracy on a monumental scale. The true innovation was not just in knowing how to cut stone, but in knowing how to coordinate human beings. How do you ensure that the block the quarry team delivers is the exact size and shape the setting team needs when they are working miles apart? The answer lies in a rigid system of quality control and standardized measurement. Master craftsmen would have inspected every block at every stage of its journey. They likely used templates and calibrated measuring rods to verify dimensions, rejecting any piece that did not meet the exacting standard. This created a culture where perfection was not an aspiration, it was a baseline requirement. Knowledge was not written down in manuals, but passed directly from master to apprentice through years of hands-on training. An apprentice would spend a decade perhaps just learning how to mix and apply the diamond dust abrasive for polishing granite. This slow, meticulous transmission of skill ensured that technical secrets were not lost, but were refined and improved with each new generation. The stones themselves are the final proof of this incredible social organization. Their perfection is a testament to a society that understood how to marshal human talent, discipline, and knowledge on a scale that rivals any modern corporation. The greatest structure they built was not made of stone but of people, a collaborative human machine engineered for one purpose: to turn a vision of cosmic harmony into an enduring physical reality. Yet the very fragility of this knowledge is what makes its loss so profound. These were not mere construction manuals that were burned, but living traditions that died with their masters. When the Spanish conquistadors toppled the Aztec and Incan empires, they did more than just dismantle governments, they systematically dismantled cultures. They melted gold artifacts, tore down temples, and most devastatingly, targeted the priestly and artisan classes who held the specialized knowledge of their people. In a single, violent century, entire libraries of applied science, refined over thousands of years, were extinguished. The precise formula for a plant-based stone softener, the specific resonant frequency needed to make granite pliable, the exact mixture for a geopolymer concrete, these were secrets held in the minds of a select few. With those minds silenced, the techniques vanished from the earth as if they had never existed. This same pattern of loss echoes from the earlier collapse of Bronze Age societies across the Mediterranean. An interconnected network of empires from the Mycenaeans to the Hittites fell into a dark age, taking with them advanced technologies like the precise corbelled arch and intricate stone inlay work. The knowledge of how to move multi-ton megaliths was forgotten for centuries. This recurring historical cycle suggests a sobering truth that our current understanding of the ancient world is built on the scattered ruins of a much richer technological landscape. We are left studying the footprints, not the runner. The lost knowledge represents more than just technical methods. It signifies entire worldviews. For these cultures, stonework was not a separate discipline from astronomy or spirituality. It was an integrated expression of them. To carve a stone to perfect alignment with a star was a spiritual act. To mix a slurry that could transform rock was an alchemical ritual. The separation we see today between science, art, and religion did not exist for them. Their most advanced engineering was inextricably woven into their cosmology, a holistic understanding of a living, interconnected universe. This is why we struggle to reverse engineer their achievements with our fragmented, specialized sciences. We are trying to read a book where most of the pages have been torn out, and the few remaining paragraphs are in a language we no longer fully understand. What grand chapters of human ingenuity are missing from our story, and what might we learn about our own potential if we could only hear their whispers in the stone? Modern engineers have tried to match the ancients, and the results are humbling. In one ambitious project, a team equipped with copper chisels, stone hammers, and ropes attempted to quarry and shape a granite block using only the tools we believe were available. After weeks of grueling labor, they produced a rough, pitted stone that bore little resemblance to the flawless artifacts found in Egypt. The copper tools blunted almost immediately against the hard granite, and achieving anything close to a smooth surface proved nearly impossible. The experiment revealed a stark truth: our assumptions about primitive tools are likely wrong. Another group, using diamond-tipped saws and computer-guided machinery, managed to replicate the precision of the stonework, but the process was incredibly slow and energy-intensive. They could match the form, but not the efficiency. The ancient builders, it seems, moved with a speed and confidence that our most advanced technology cannot explain. This gap between our best efforts and their everyday work suggests a fundamental piece of the puzzle is still missing. We are trying to solve their equation with only half the variables. Perhaps it was not the tools themselves, but the complete system, a seamless integration of chemistry, acoustics, and logistics that we have failed to grasp. Our failures in replication are not a sign of our weakness, but a testament to their profound and still elusive strength. What must we unlearn about the past before we can truly understand how these stones were shaped? A single beam of sunlight was their most demanding client. The ancient builders were not just erecting walls, they were calibrating instruments of immense scale, where a misplaced inch could mean the difference between a perfect solstice alignment and a failed prophecy. This relentless demand for celestial accuracy became the ultimate crucible for their stoneworking skills. To track the slow precession of the stars or mark the sun's turning points with unerring precision, they needed to carve and place stones with a level of exactitude that went far beyond structural necessity. A doorway that was even a fraction of a degree out of true would fail to frame the rising of a specific star. A shadow-casting pillar that was not perfectly vertical would tell the wrong time for generations. Their architecture was a permanent conversation with the cosmos, and every stone was a carefully chosen word in that dialogue. This practical, urgent need to measure the heavens is likely what forced the evolution of their techniques from simple construction to what we would now call precision engineering. The quest to capture a sunbeam at a specific moment on a specific day drove the invention of the flawless joint, the optically flat surface, and the perfectly plumb wall. The stone itself became a medium for capturing and measuring cosmic movements, a physical manifestation of time and space. Why pour such incredible effort into a single, seamless block? Because that block was the anchor point for a shaft of light that would define a season, a ceremony, or an entire calendar. Their greatest technological achievements were not born from a desire to build bigger, but from a profound need to see more clearly into the workings of the universe, turning entire mountains into silent, steadfast witnesses to the cosmic clock. The stone's journey toward perfection began not at the construction site, but deep within the quarry, where the raw rock was first persuaded to let go of its future form. This was not a process of brutal extraction, but one of careful revelation. The builders approached a cliff face not as a solid mass to be broken apart, but as a repository of pre-formed blocks, each one waiting to be unlocked. Their first task was to see the final block hidden within the unworked stone, a skill that combined geometry, intuition, and an intimate knowledge of the rock's hidden flaws and grain. They likely used sophisticated marking systems, painting precise lines directly onto the rock surface with ochre or charcoal. These were not simple guidelines, they were the exact dimensions of the block as it would appear in the final wall, a blueprint drawn directly onto the raw material. In some quarries, you can still find the cut channels for wooden wedges, placed with such exact spacing that when the wedges were soaked with water to expand, the stone would crack perfectly along the intended line, leaving a clean, nearly finished face. This method required an incredible understanding of tensile strength and fracture mechanics. They knew just how much force to apply and where to apply it to guide the stone's own internal stresses to do the work for them. The goal was to extract a block that required the absolute minimum of finishing labor later. A block quarried with this level of foresight would already have its primary surfaces nearly flat and its angles correctly formed, saving weeks of grinding and shaping at the building site. This quarrying precision was the foundational act of the entire enterprise. A single error here, a misjudged fracture or an incorrectly painted line, would render the stone useless for the seamless joints and celestial alignments that were to come. The builders were not just cutting stone from the earth, they were liberating a precise component from a living mountain, treating the quarry as the first and most critical phase of construction, where the vision for a perfect wall was born in the dust and rock. This profound understanding of stone began with an intimate knowledge of the earth itself. Ancient builders were not just skilled artisans, they were master geologists who selected their materials with a scientist's precision. They knew that different stones possessed different souls, and they chose each one for a specific purpose. For the immense foundation blocks of a temple that had to bear crushing weight, they sought out dense igneous rocks like granite and basalt, stones with incredible compressive strength. For the intricate inner chambers where fine carvings and celestial alignments were critical, they might select a softer limestone or a dense diorite that could hold a razor-sharp edge and accept a perfect polish. They even understood long-term weathering, choosing certain types of sandstone for their resistance to wind and water erosion, ensuring their monuments would endure for millennia. This was not a random selection from the nearest hillside. It was a deliberate, calculated process based on a deep, accumulated knowledge of material properties. This wisdom likely grew from centuries, even millennia, of careful observation and experimentation. A master mason would have known that granite from one specific quarry was finer grained and better for drilling, while basalt from another region was less prone to fracturing under thermal stress. This knowledge became a sacred trust passed down not in books, but from master to apprentice within closed guilds or family lineages. A father would teach his son not just how to cut a stone, but how to read it, to understand its hidden flaws and its inherent strengths by the sound it made when struck, by the color of its dust, by the way it fractured under a hammer. They were practicing a form of proto-material science, classifying rocks by their performance long before we had modern laboratories to quantify their properties. Modern analysis of these ancient sites confirms this sophisticated selection. Scientific instruments can detect that the stones used for the most critical load-bearing corners are consistently of a higher quality and density than those used in the less stressed wall sections. This reveals a systematic application of engineering principles, an optimization of resources that rivals our own modern construction codes. Their material selection was a language where every stone chosen spoke of its function and its destiny within the greater whole. What does it tell us about these cultures that their most enduring legacy is built upon a forgotten science of the earth? A conversation with stone that we are only now beginning to decode with our most advanced machines. Perhaps the most overlooked tool in the ancient builder's workshop was the human mind itself. Achieving that microscopic level of precision required more than just sharp tools and strong arms. It demanded a state of profound mental focus that we can scarcely comprehend today. Each cut, each polish, each final placement was an act of deep concentration, where a single moment of distraction could ruin weeks of labor. It is not difficult to imagine these artisans employing techniques akin to meditation or rhythmic chanting to enter a flow state, a mental zone where the hand, the eye, and the tool became a single, unified instrument. They were not just cutting stone, they were in a silent dialogue with it, feeling for the subtle grain and hidden faults, visualizing the final, perfect form hidden within the raw block before a single strike was made. This was not a job, it was a spiritual discipline. The work itself was a form of prayer, a sacred act of bringing cosmic order out of earthly chaos. This explains why our modern replication attempts so often fall short. We arrive with our scientific hypotheses and our reconstructed tools, but we bring a modern, hurried mindset. We focus on the how, but they understood the why. For them, a perfect joint was not merely a technical achievement. It was a moral and spiritual imperative, a reflection of harmony in the universe. The stone was not an inanimate object to be conquered, but a partner in a grand collaborative creation. This sacred attention, this reverent focus, infused every action with a significance that transcended mere construction. We have spent centuries searching for their lost machines and forgotten chemicals, but the most vital ingredient may have been a state of mind, a psychological framework that saw perfection not as a goal, but as the only acceptable path. The stones did not simply rest against one another, they were locked in a permanent embrace. Across the ancient world, builders employed a secret language of geometry to create joints that actively resisted shifting and settling. At sites like Ollantaytambo, you can find massive granite blocks connected with dovetail joints, the same interlocking technique a master carpenter would use to join two pieces of wood. These are not simple grooves, they are complex precision-cut channels where a separate piece of stone, shaped like an hourglass or a butterfly, was slotted in from above. This butterfly clamp, once set, physically binds the two colossal blocks together, preventing any lateral movement. The entire structure is transformed from a stack of heavy stones into a single, unified mass, its strength derived not from glue or mortar, but from the immutable laws of geometry. The cutting of these joints required an almost impossible foresight. Each channel had to be carved with microscopic accuracy, not just in one block, but in its neighbor simultaneously. An error of even a few millimeters would mean the clamp would not fit, rendering the entire block useless and wasting months of labor. This indicates the builders worked from a master plan, a detailed blueprint that accounted for the final position of every single stone and its unique locking mechanism. They were not just thinking about how a block fit in the moment, but how the forces of gravity, earthquakes, and time would act upon it for centuries to come. This joinery technology is a brilliant fusion of disciplines, taking the trusted principles of woodworking and scaling them up to a monumental level in stone. It reveals a mind that saw the underlying structural principles common to all materials, understanding that a well-designed joint in wood and a well-designed joint in stone both serve the same purpose: to distribute force and create unshakable stability. Why rely on crushing weight alone when you could use clever design to make the stones hold each other in place? This is the pinnacle of intelligent engineering, where the shape of the stone itself becomes its greatest source of strength. This relentless pursuit of perfection was never just about engineering. The drive to carve stones with microscopic accuracy and align them to the stars was fueled by something far deeper than technical ambition. For these ancient cultures, the very act of building was a spiritual duty, a way of bringing human creation into harmony with a divine cosmic order. A wall that was perfectly straight mirrored the unwavering path of a celestial body. A seamless joint reflected the unbroken unity of the universe. This was architecture as a form of prayer, where every precisely placed block was a verse in a physical hymn to the gods. The stones themselves were not inert materials, they were sacred vessels. To shape granite into a flawless surface was to imitate the perfection of the heavens. To orient a temple to the solstice sun was to participate directly in the cycles of creation. This spiritual context transforms what we see as impractical precision into something utterly essential. Why spend generations achieving a finish that no human eye could possibly appreciate? Because the work was not for human eyes alone. It was an offering, a permanent record of a culture's understanding of its place in a vast, ordered cosmos. The mathematical constants encoded in the Great Pyramid, the golden ratio, the alignment with true north, these were not hidden secrets. They were the foundational principles of their worldview, made visible and eternal in stone. The builders were not constructing mere tombs or temples. They were building bridges between the earthly and the divine, creating spaces where the sacred could enter the world. This explains the superhuman patience, the generational dedication. A modern construction project has a budget and a deadline, but a sacred duty to the cosmos is timeless. Their motivation was not to solve a practical problem, but to fulfill a spiritual imperative. The impossible precision we struggle to explain becomes perfectly logical when you realize they were not building for this world alone, but for the one they believed watched from the stars. Their greatest legacy may not be the stones they left behind, but the breathtaking vision of a universe where human effort could touch the divine. The tools in a modern stonemason's workshop tell a quiet story of inheritance. Though his saws are now powered by electricity and his measuring devices are digital, the fundamental principles guiding his hands are ancient echoes. When he stretches a simple string line to mark a perfectly straight cut, he is using the same geometric truth that ensured the Great Pyramid's flawless base. When he checks his work with a water level, a tube filled with liquid that finds a true horizontal plane regardless of the terrain, he is employing a method that would have been utterly familiar to the builders of Sacsayhuamán. These are not modern inventions, but living traditions, tools of the mind passed down through generations, their origins faded into the practical silence of daily work. The master mason knows these techniques work, but he may not know they are the legacy of a lost science that once oriented entire temples to the stars. In the construction of a cathedral or the restoration of a national monument, the same reliance on templates and standardized measurements ensures that stones carved by different artisans in different locations will still fit together seamlessly, a direct descendant of the quality control system that built the ancient world. This unbroken thread of practical knowledge connects a 21st century artisan to his Bronze Age predecessors, a lineage of precision written not in books, but in the muscle memory of the craft itself. By looking back and truly understanding why these ancient methods were so vital, modern craftsmen can rediscover the profound principles behind them. It is one thing to use a string line, it is another to comprehend the cosmic ambition that demanded such perfect straightness in the first place. This deeper understanding can elevate modern stonework from mere construction to something approaching that old harmony, blending timeless technique with the soul of the ancient masters. Their secrets may be fragmented, but their influence is chiseled into the very foundations of our most enduring structures, a permanent reminder that what we consider cutting edge in stone was often perfected millennia ago. These silent stones are more than monuments, they are a profound question posed to our modern world. The secrets of the ancient builders reveal a relationship with the material world that we have largely forgotten, one where humanity, stone, and cosmos were partners in a single grand design. Their achievements stand as a permanent challenge to our linear narrative of progress, forcing us to wonder if our current technological path is the only one, or merely the loudest. We measure advancement in processing power and engine output, while they measured it in harmony with the earth and alignment with the stars. We may never fully recover the formula for their stone softening plants or the resonant frequency that made granite pliable, and perhaps that is not the most important lesson. The true value of this pursuit is the humility it teaches us, and the breathtaking expansion of what we believe human potential can be. These enduring stone mysteries invite us to look at all of history with fresh, curious eyes, to question the accepted stories and listen for the whispers of lost wisdom in the wind. For if they could achieve such miracles with the world around them, what forgotten solutions to our modern challenges, from sustainable building to energy efficiency, might be hidden in plain sight, encoded in the very structures we walk past every day? Look more closely at the ancient walls in your own world. What silent secrets might they be holding, waiting only for a curious mind to ask the right question? Share what you believe is our greatest unanswered question about the past in the comments below, and join me as we continue to explore history's greatest puzzles together.